Create a Python Wordle clone with Rich. In this course, you'll build your own Wordle clone for the terminal. Since Wordle was launched in October 2021, millions of people have played it. While you can play the original game on the web, you'll create your version as a command line application and then use the Rich library to make it look good. As you follow along in this step-by-step course, you'll practice how to set up a simple prototype game before iteratively developing it into a solid application. You'll learn how to build out a command line application from a prototype to a polished game, read and validate user input, organize your code into functions, provide your users with actionable feedback, and use Rich's console to create an attractive user interface in the terminal. This project is for anyone getting comfortable with Python who wants to build a terminal application from the ground up. Throughout the course, you'll build your code step by step while focusing on having a game that you can play from the very start. Don't forget to download the course materials. Included as part of them is the code at the end of each major section of the course, which will allow you to compare your code and fix any issues that may crop up along the way. Any code that you see running in the REPL will be using the bpython interpreter. This is a replacement Python interpreter that offers a number of enhancements, including code highlighting and suggestions, but any code you see running on screen will work in the standard Python REPL, which is typically accessed by typing Python or Python 3 at your terminal or command line prompt. While working through the steps, it's helpful if you're comfortable with the following concepts: reading input from the user at the terminal, using if statements to check different conditions, repeating actions with for and while loops, organizing data in structures such as lists and dictionaries, and encapsulating code with functions. If you're not confident in your knowledge of these concepts, then that's okay. Going through this course will help you practice them. If you get stuck, Real Python has you covered with resources that will get you back on track. So now you know what's going to be covered, let's get started by taking a look at what you'll be building. Project demo and overview. In Wordle, you have 6 attempts to guess a secret 5-letter word. After each guess, you'll get feedback about which letters are correctly placed, which are misplaced, and which are wrong. The New York Times bought the original Wordle in early 2022, and you can now play the game on their website. The game has a social aspect that you won't recreate in this project. The New York Times version of the game has 1 secret word per day, and all the players are guessing the same word. Your version of the game will look as seen on screen. After you make a guess, each letter is categorized. Correct letters are marked in green, misplaced letters are marked in yellow, and wrong letters are marked in grey. If you make any mistakes, such as guessing a word with 6 letters, then the game will give you appropriate feedback and let you take another guess. An important part of this project is bootstrapping the application early. You want to have code that runs so that you can test that the code works, and you can experiment with different ways of implementing the features that you need in the game. You'll build your Wordle clone iteratively, going through the steps seen on screen. Creating a simple prototype that allows you to guess a secret word and gives you feedback on the individual letters. Making the game more interesting by including a list of words that the game randomly chooses from. Refactoring the code to use functions, adding color and style to the game using the Rich library, providing actionable feedback to your users when they play the game, and improving the user interface by adding the status of all the letters in the alphabet. As you work through the course, you'll see how you can start with a small idea and grow it into a full-featured application. After all, that was Wordle's journey, and in the next section of the course, you'll start yours. Guess a word. In this section of the course, you'll build a very basic word-guessing game. The game won't look good, and the feedback from it will be hard to pass if it's present at all. Still, the building blocks for your Wordle clone will be in place. By the end of this phase of the project, you'll use input to read words from your players, a for loop to give your users several guesses, and sets to find out which letters your users have guessed correctly. You can get information from the user with input. This built-in function is a great way to provide simple interactivity on the command line. Open the REPL and try it out. Enter the code seen on screen. you can provide an optional prompt to input. The user will see this before they enter any information, and as you can see, the line shows both the prompt and the user input at the same time. The prompt asks the user to guess the word, and the user enters snake and then hits enter. The call to input returns the text that the user enters. You can see this in this example as the string snake has been assigned to guess. It's never too early to start building your game. Open your editor, create the file wordle.py and enter the code as seen on screen. After you've read the user's guess, you can check whether the guess is equal to the secret word snake. You evaluate their guess and inform them whether they were correct or not. It's usually a good idea to create code that runs as early as possible. Even if it's just doing something small and is far away from your end goals, making it runnable means you can start experimenting, testing, and debugging. Now, this may not look like much of a game, and even if you do think of it as one, it's probably fairly boring. There's little replayability because the secret word is always the same, and the feedback isn't actionable for the user since they don't learn much from just being told that they're wrong. You'll soon improve this and make something more interesting to play. But first, you need to fix a small usability issue. Consider the game seen on screen. You correctly guessed that the secret word is snake, but the game tells you that it's wrong because it's comparing your guess to the uppercase string snake. Here, the goal is to guess words and not to figure out whether the letters are lower or uppercase. So how can you compare two words regardless of what their case is? The simplest solution is probably to explicitly convert the guess to uppercase. Then it doesn't matter how the user inputs the word. Adding upper forces the user's guess to be in uppercase. This manipulation immediately makes the game more user-friendly. The lowercase snake guess is now reported as correct. But still, you're only giving your users one chance to guess correctly, and next you'll expand the game with more guesses. Use loops to avoid repetitive code. When playing Wordle, you get up to 6 chances to guess the correct word. One way to achieve the same in your game would be to copy the code that you've already written and repeat it 6 times. But that's a bad idea for several reasons. Most importantly, it would be inefficient and complicated to maintain. Instead, you'll use loops to achieve the repeating behavior. Python supports 2 main looping constructs, for and while. Typically, you'll use for when doing definite iteration. You know in advance how many times you want to loop. On the other hand, while is great for indefinite iteration, where you don't know upfront how many times you need to repeat an action. There are other ways to create loops. Some programming languages rely on recursive function calls to create loops. And later in this course, you'll see an example of using a recursive loop in Python as well. In general though, you shouldn't use recursion for looping in Python. Function calls are quite slow, and there are no optimizations for recursion as you may find in other languages. Usually, you'll be better off sticking to regular loops. Here, you want to ask the user 6 times to guess the word, so you'll use a for loop. By looping over range, you'll also count the number of guesses and display that number to the user. There's no point in letting the user keep guessing once they've found the correct answer, so you use a break statement to break out of the loop early if the user guesses the right word. An additional bonus of introducing break is that you don't need the explicit else anymore. Your code only continues if the guess is wrong. You can see the latest version of the code in action on screen. Next, it's time to make the game more playable by adding some proper feedback. In the next section of the course, you'll see how you can enumerate which letters the user has guessed correctly. Check letters with sets. So far, you've only told the user whether they've guessed the entire word correctly or not. To give some hints to allow them to deduce the secret word, you'll add feedback about the individual letters they guess. You'll classify each letter as belonging to one of 3 categories seen on screen. A correct letter appears in the same position in the guess as in the secret word. A misplaced letter appears in the secret word, but in a different position, and a wrong letter doesn't appear in the secret word at all. On screen, you can see some guesses classified when the secret word is snake. But how can you find out which letters belong in each category? You'd start by figuring out which letters are correctly placed. Python's zip function is great for doing element-by-element comparisons of 2 sequences. In this case, you're comparing the letters of 2 strings. In this piece of code, you find the 2 correctly placed letters in crane by comparing snake and crane 1 letter at a time. Even though there's an N in both words, it's not reported since it's in different positions. Now you need to collect the letters and not just print them out. Comprehensions are powerful constructions in Python that you use to transform one or more sequences into another. Here you'll use a set comprehension to collect the correct letters. A set comprehension is similar to a list comprehension, but outputs a set instead of a list. It works well in this situation because the order of the correct letters isn't important. One advantage of sets is that Python offers powerful operations on them. You can quickly use unions, intersections, and differences between 2 sets to find elements that appear in at least one set, both sets, or only one of the sets. For example, if you have 2 strings, then you can use set intersection to find all the letters that appear in both. The intersection tells you that A, E, and N are both in snake and crane. Similarly, you can use the set difference to find letters that appear in one set and not the other. C and R are the letters in crane that don't appear in snake. Note that the intersection, union, and difference operators in sets are used to implement set theoretic operations in Python, and these are different from Boolean logic operators such as AND, OR, and NOT. It's time to use sets to improve the game. However, before you start the implementation, you'll make one other change. Currently, you've hard-coded the secret word into the if test. You'll use that word when you classify letters, so instead you'll refer to it using a constant. Introducing the word constant makes it easier to change the secret word. In the next section, you'll add a word list that you'll choose the word from, making the game more interesting. Using what you've explored previously about sets, you can now calculate and display the correct, misplaced, and wrong letters. Update the code as seen on screen. You use the set comprehension to find all the correctly placed letters. The misplaced letters are the ones that are in both the guess and the secret word, but aren't correctly placed. Finally, the letters in the guess that aren't in the secret word at all are categorized as wrong. For now, as seen on screen, you're only listing the categories and the letters. While the information is there, it's not so easy to understand. Later on in the course, you'll improve the user interface and make the game both nicer to look at and nicer to play. But before that, you need to improve the game's variety by creating a word list, so that's what you'll be looking at next. Use a word list. In this part of the course, you won't change the functionality of your game, but you'll make it more fun and replayable by adding a word list. So far, the secret word is always the same. That is about to change. To do this, you'll first create a small word list manually and integrate it into the game. Then you'll explore how to turn any text into a word list. Your word list will be a plain text file containing one word per line. This follows a long tradition on Unix systems where a file named words is used by spell checkers and similar applications. To get started, create a new file you call wordlist.txt with the content seen on screen. Here, you're adding words that could be the secret word. Feel free to expand the list yourself. But don't put too much effort into it, as soon you'll be creating the word list automatically. Before creating the better word list, you'll see how you can read the list of words into your program. Python's pathlib module is great for working with files and reading them into memory. You can try it out in the REPL. The read text method reads the whole thing as one text string. Note that the \n symbols separate the words. These represent new lines in the file. You can strip off the last new line and split on the rest to convert the file into a list of words. You use strip to remove any extra lines at the end of the file, and split to convert the file into a list of words. To avoid having to care about lower and uppercase, you convert all the words to uppercase. You're now able to include a list of words in your program. But how can you choose one random word from that word list? Python comes with a powerful random module in the standard library. You can use it to generate all kinds of randomness in your projects. Here, you'll use random choice, which randomly chooses one item from a sequence. As you can see, sometimes randomness gives you the same answer twice in a row. Your results will likely be different from the ones seen on screen. But it's time to add word list functionality to the Wordle clone. Edit the game as seen on screen. First, the constant word is removed, as you'll be replacing it with the code you're about to enter. You import pathlib and random, as they'll be used as you saw previously in the REPL. The words are read from the word list and processed appropriately. A word is then randomly chosen from the list. The final edits to make are to replace the previous constant word with the new variable word, now in lowercase, to show that it's no longer a constant. One small frustration is that if you don't guess the word correctly, you'll never get to know which secret word was chosen. To fix that, add these lines at the end of your code. It's not common to use the else clause with for, but it's quite powerful in the right situation. The code inside the else will only run if the for loop terminates naturally. But it won't run if that isn't the case. Here, if break stops the loop. In practice, this means that the secret word is printed if all the guesses are different from word. While you're developing your game, you'll run it many times. To test your code effectively, you may want to cheat and know the secret word up front. While testing your code, add the line seen on screen just before calling input, and this will print the secret word to the console. Try running the game a few times. It's already more challenging and fun since you don't know the exact word up front. But with a limited word list, the game gets repetitive. So in the next part of the course, you'll look at a method to create larger word lists. Convert text into a word list. You probably already have a word list on your system, and you can download word lists online. But for flexibility and control, you may want to create your own. This allows you to create special, themed word lists containing programming-related terms, city names, or non-English words, amongst many other options. You'll create a script that converts any text file into a nicely formatted word list that you can use in your Wordle clone. Add a new file named createwordlist.py to your project with the content seen on screen. The script uses sys-argv to read information from the command line. In particular, you're expected to provide the path to an existing text file and the location of the new word list file. The first two command line arguments are converted to paths, named inPath and outPath. This line acts as a filter in your set comprehension and won't pass through words that contain any character that isn't ASCII. In practice, it only allows the letters A to Z. Note that key has two arguments passed to it. The first is a lambda expression, sorting the words by length in ascending order. The second is the word itself, allowing words of equal length to be sorted in alphabetical order. This isn't strictly necessary, but makes reading the list easier. Finally, the word list is written to the output file at the path specified in the second argument. Once saved, you can use the script to convert your current version of Wordle to a word list as seen on screen. This reads Wordle.py, looks for words, and stores them in wordlist.txt in the current directory. Note that this overwrites the word list which you created manually. Take a look at your new word list. You'll recognize some of the words from your code. However, note that only some words went into the word list. Also, take note of the fact you don't filter out words that are more or less than 5 letters long. You could do that when you're building the word list, but by leaving that job for your Wordle.py code, you gain some flexibility. This makes it possible to use a general word list and to change the word length in the game. Maybe you want to create a Wordle variant that quizzes the user about 7-letter words. You can now generate your personal word list. Find any plaintext file and run createwordlist.py on it. You could, for example, download the complete works of Shakespeare to create an old-style word list, or a version of Alice in Wonderland retold in words of one syllable to create a list of simpler words. Since your word list now contains words that aren't 5 letters long, you should add a filter to your list comprehension that passes the word list. Start by importing ASCII letters, remove strip since empty words will be filtered in the next line, which filters on length and ensures the words only contain ASCII letters. Remember that you can check your code against the code in the course materials if you have any problems running the game. There are versions of the files included for each numbered section of the course, so you should be able to get back on track if you need to, but also remember that it's worth spending some time looking at code that doesn't work and seeing if you can figure out what's happening that isn't intended. This is a key skill that you'll use a lot. Your game is more interesting now that the secret word is chosen at random from a word list. And later on in the course, you'll work on making the user experience nicer with more intuitive feedback. But first, you'll reorganize your code so it will be easier to work with in the long run.